Hey class, this is Mr. Roberts at Shasta High School, and we're going to take a look at the study team test that we took in class. This is 2019, what is it, April? Um, some of these questions were multiple choice, some were short answer. We're gonna take a look at them all, and hopefully get you squared away for the individual tests coming up this Friday. So the first question says simplify the expression. Simplification, we're looking for no common factors and no negative exponents. One of the things that I think it was this chapter, or maybe it was in chapter 8, that they introduced was this idea that if you have a fraction raised to a negative exponent, there's kind of a cool thing that happens. So, for example, if I have this fraction like 1/4 and I raise that to the negative second power, I want you to demonstrate what happens on this calculator, right? So I'm turning it on. I'm going to go ahead and grab the really cool fraction template. I'm going to have a numerator of 1, a denominator of 4. That's a chunk because it's a rational expression 1/4, so I don't need parentheses around it. I'm going to raise that thing to the negative second power. One thing I don't like about this notation is it appears that maybe I'm just raising the numerator to the negative second power, but the way that I constructed that, it's 1/4, and then that's to the negative second. So when I do it, I get the number, surprise, 16. And the reason why that is if we have a negative exponent, we can clear the negative exponent by turning it into a reciprocal of the fraction and then raising it to the power of 2 in this case, the positive power. So in general, if you've got like a fraction like 1 over or x over y, and you're raising that to the, I don't know, negative a power, that's going to be equivalent to y over x, and then you're going to raise that to the a power. So not that you want to remember x and y's and all this stuff. Just kind of think about the idea that if you have some rational number, ratio of two numbers, rational number, and you raise it to a negative power, that this is what it becomes, which is 16. So let's take a look at this. So I've got x squared over 6 times x, and I'm raising that to the negative second power. The first thing I want to do is I'm going to actually clean up this part inside of the parentheses, right? There, that could be cleaned up a little bit because there's a common factor of x in the numerator and denominator. If I'm real clear, that numerator is x times x and the denominator is 6 times x. All this is being raised to the negative second power. So what I'm saying is there's this common factor here. There's this giant 1. So I can rewrite this as x over 6 raised to the negative second power. And then when I take the reciprocal of that, it becomes 6 over x, and I'm squaring it. Well, if I square both the numerator and the denominator, I would get 6 squared, or 36 in the numerator, and x to the second power in my denominator. So the correct answer for that was, I can't say A, B, C, or D because it's shuffled around the order, but it's this one. It's the one that matches, right? 36 over x squared. Let's move to number 2. On question 2, if we're going to square both sides of this, you can do that, but I want you to know that there's more complexity if you're just squaring both sides of this thing. And it comes down to the fact that this left-hand side is a binomial, right? It's like, pretend it's like 5 minus 2. And you're like, it's not 5 minus 2, Mr. Roberts. It's the square root of x minus 6 minus 19. How's that 5 minus 2? The problem that I see some of you doing is you're under the impression that if you want to square that side, you get away with doing that by just simply squaring the 5 and squaring the 2, and that's not the case, right? The answer to this, 5 minus 2 is 3, 3 squared is 9. The answer of that's 9, and if you were to square each one of those, you would get 25 minus 4, which is 21. Clearly, squaring these individual terms is not the same as squaring this binomial. So again, whenever you see multiple terms, right, things separated by plus or minus, think about this area model until you're really clear with what's going on. So I've got a 5 and a negative 2, a 5 and a negative 2. And I know you're thinking, but can't I just do 5 minus 3 and square it? Yeah, you can, right? I'm trying to show you how you would deal with this from the variable point of view when you've got variables like x in it. Or in this case, my variable, I've got this thing minus this thing, and I'm squaring this whole quantity. So if I was to do this, this is 25, this is a negative 4. But then you can also see there is a negative 10 and there is a here. Okay, well this is a negative 10, but this is not negative 4. This is positive 4 because I've got negative 2 times negative 2 is positive 4. So when I look at this, right, together there is a 25, and then there's minus 2 tens or minus 20, and then there is a plus 4. Well, 25 minus 20 is 5, and 5 plus 4 is 9. So you can see when you think about squaring this binomial and you do this the correct way, right, you do get 9. So why am I saying this? Well, if you wanted to, you could square this binomial, right? And binomial, I mean, there's this 19 that's negative and there's this thing, and square it out like that. I think a better strategy would be to just get rid of the negative 19 on the left hand side by adding that to both sides. So I'm going to rewrite this as the square root of x minus 6, and that's going to equal negative 2 plus 19, which should be positive 17, I think, right? Maybe 17. Yeah, it is. So the question is, well, what do you take the square root of to get 17? And I have absolutely no idea. But now that I have a monomial on each side, it's pretty reasonable for me to say, look, I'm going to square this side and I'm going to square this side. Now, please look at this and pay close attention, right? This is a monomial, right? It's just the x minus 6, but because that's all in the square root symbol, it's a chunk, right? It's a thing. It's not like this where I had two things, a term and another term, right? This is just a single term. Inside of the radical, there are two different terms, but looking at this, it's just a term. So when I square that side, I get x minus 6. You know what? Another way to look at that too is this. I know that the square root of x minus 6 is the same thing as x minus 6 to the 1/2 power, because we've talked about this. If I raise something to the 1/2 power, it's the same thing as taking the square root. So if I look at this, if I take the square root of x minus 6, that's x minus 6 to the 1/2 power, and I square that, right, what do I end up with? I end up with the 1/2 times the 2, which gives me the 1. So this legit is x minus 6, and it equals whatever 17 squared is. And I got to be honest, I forgot. I don't know what that is. 17 to the second power. It's 289. And then as a final step then to solve for x, I'm just going to add 6 to both sides. And when I add 6 to both sides, we end up with 295. So x is 295. And of course, if I plug that back in, it'll work perfectly well, right? 295 minus 6 is 289. I take the square root of 289 and I get 17, and 17 minus 19 is negative 2. So, hey, one of the things I really want to caution you of is, yes, this is multiple choice and correct. You could plug in each one of these until you find the value that works. The thing that's dangerous about that is you see how I can give answers where you have to type responses, right? So don't rely on don't get stuck in using that crutch for multiple choice questions. Be thinking about how you can get the answer and then just use it as verification. On number 3, if I look at this, probably the first thing I'm thinking is I want to get rid of this divide by 11. So I'm going to use fraction busters and multiply both sides of this by 11 over 1. Over on the left-hand side, when I multiply x over 11 times 11, I just get simply x. And then 7 times 11 is 77, and then that's minus 11x. I'm going to add 11x to both sides. That gives me that 12x is 77. Therefore, x is 77 divided by 12. So that's what the answer is, and it's great confirmation that it's there. One cautionary tale is just because the answer that we get shows up doesn't mean it's automatically correct, right? It could be a good distractor. So it's often nice to just go ahead and build that fraction. So if I was to hit alpha and I could look at this fraction template, and I've got the 70, what did I say it was? 77 over 12. Oh, it's right there, 77 over 12. That's the fraction. And if I take that thing, got it, and I divide by 11, yeah, I get 7/12. That should be exactly the same as if I take the number 7 and I subtract this fraction again. So this should give me this thing should give me 7/12, and lo and behold, it does. So not only is it there as an answer that's possible, but it worked, right? When I plugged it in, it's clearly the solution. Let's move on to question number 4. It says solve for x hand rewrite so that all bases are the same. So when I take a look at this, the 9, I'm thinking 3, and 27, right? That's 9 times 3. So I'm thinking I need to switch to a common base of 3. And a lot of times, just to clarify my thinking, I might consider different powers of 3 and what they equal. So for example, I could look at 3 to the 0 power, which is the number 1. I could write 3 to the first, which is 3. 3 to the second is 9, and 3 to the third is 27. And I can also go the other way, right? 3 to the negative 1 is 1/3. 3 to the negative second is 1/9. 3 to the negative third, right? It's like that reciprocal thing we were just talking about, right? It's 1/3 to the positive third. So it's 1/3, 1/3, 1/3, which is 1/27. So what I'm noticing is that I have this number 27. I can build that. That's the same as 3 to the third. And for some reason, the third didn't wash out there. So that 27 is the same thing as 3 to the third. And the other thing that I've got is this 1/9, right? We can write that as 3 to the negative second power. So here's our rewriting so the bases are the same. I'm going to change this up. I'm going to write this as 3 to the third, that's 27, parentheses. And I'm going to raise that to the 3x plus 2, just like I did on this side. On the other side, you know, let me, oh, no keyboard. Let me get some room here. Love that. I love that I could just kick that over there. Let's see, this one I've got 1/9, which we said was 3 to the negative second power, and I'm going to raise that to the x minus 1 power. So what I have here is I have a situation where I'm raising a power to a power, so the operation's multiplication. So on the left hand side, this is going to become 3 to the 9x plus 6. Be very careful, right? It's this exponent times this exponent. So I need to multiply the 3 by both the 3x and by the 9, right? I'm distributing that multiplication across that addition problem. On the other side then, using the same thing, we've got 3 to the negative 2x and then plus the number 2. So because these have identical bases now, we understand that this exponent right here, right, has to be, that's just sloppy. Why did I do that? Let's do this. This has to be the exact same as this. So we're just going to set those equal to each other. If the bases are the same, there's no way that these quantities can be equal if the bases themselves, or the exponents themselves, aren't equal, since the bases are the same. So we're just figuring out what value of x would make 6 or 9 times x plus 6 the same as negative 2x plus 2. I'm going to add 2x to both sides. That's 9, 10, 11. So I get 11x. Plus 6 is positive 2. Subtract 6 from both sides, that's 11x is negative 4. And yeah, when I divide by the number 11, I get that x is negative 4/11. So that is the correct solution, and you can see it's right here also. On to number 5, it says solve for w. Okay, this is great because there's a g here also. So to solve for w, I think the first thing I'm going to do is I'm going to go ahead and add 8 to both sides. So I'm going to get 5 times this, the quantity of 2w plus 3 is the same as 128 plus g. So now I'm going to distribute this 5 across this addition problem. So each one of these, there's 1, 2 terms inside of here. Each one is going to be multiplied by 5. So this is going to become 10w plus 15. And over here it's equal to 128 plus g. Let's take away 15 from both sides. So 15 away from the 28 is going to give me 8 is a 113. And then plus the g, and that's equal to 10w. And then finally, to solve for w, I'm just going to divide both sides by 10. divided by 10. And if I wanted to, this is a great answer, and this is the form that they left it in, but it could be the case that maybe they wrote the answer as 113 over 10 plus g over 10. This is the same, right? I'm dividing that binomial 113 plus g. I'm dividing both of those by 10. All right, number 6. A Honda Civic decreases by 8% each year. The current value of a particular Civic is $4,500. What was the value of the car 5 years ago? So if we were to think about writing an exponential function that modeled this situation, right? And I said that x is years and y is the cost of the car, or the value of the car. I could say the value of the car is what it's worth at year zero, $4,500 times. Now, because we are decreasing by 8%, my multiplier is going to be 1 minus 0.08, right? 1 minus 0.08, which is 0.92. If we were told it was increasing by 8%, then I would add the 0.08 and it would be 1.08, but it's decreasing by 8%, so my multiplier is 92%. That means each year that goes by, I'm preserving 92% of the value of the car, but 8% of it's going away. And then this is raised to x, the number of years I have. Now, if 0 year is right now, then when x is 1, it'd be next year, and x is 2, it's 2 years from now. If x was 5, it'd be 5 years from now. They're asking me to figure out what the value was 5 years in the past, right? So what we do is instead of entering a positive, we're gonna say 5 years in the past. So I've got 4,500 times 0.9 raised to the negative fifth power. When I do that, I get the value of the car is $6,828 if I was rounding to the nearest whole dollar, right? Round to the nearest whole dollar. So what you should have entered for your answer was exactly that, 6827, because it did say to the whole dollar, and I asked that you not include the dollar symbol. It's nice to have units, but it just makes it cleaner for me with the thing that checks these if that's not in there. Right, 7. What is the equation of the line through points C and B? Oh, Mr. Rars would apparently sleep at the wheel. What is the equation line through C and B? Well, first of all, the slope of this, right? It is important to note this does have a slope, right? Its slope is 0. That's an important distinction. If I look at this line right here, AB, this line does not have a slope. Its slope is undefined, right? Because remember, it's change in y over change in x. Well, your change in x is 0, so because you divide by 0, this does not have a slope, right? AB has no slope, but CB does. It just has a slope that's equal to 0. And the y-intercept of this is the number 5. So I can write this, right? Well, I'm going to simplify this. I can say y equals m, my slope, times x, and then plus 5, the y-intercept, or just simply y is 5. So this is what I was looking for. The answer is y is 5. Moving on. This says if triangle ABC is rotated 90 degrees clockwise about the origin, which is at 0, 0, give the location of point A prime after that rotation occurs. So interesting conversation. Someone was telling me that they'll take their page and rotate it like clockwise and then look at where the page goes. I don't know. It was some cool stuff. I usually think about it like this. So if I was to look at this line segment right here from get back over here from A all the way down to the origin, right? This line. Well, this line has a slope of down, what is it? Down 6 units and then over 4 units. So this has a slope of negative 6 over 4. I'm not going to reduce it. I'll just leave it like that. Negative 6 fourths. Well, if I was to rotate this plane 90 degrees, right, what ends up happening is I end up getting not this line that my ruler's up with, but I end up getting this line. And I should have done the math on this, but I get this line that's going to make a 90 degrees with it. And if you look at it, opposite reciprocal, right? If these lines are really perpendicular to each other, their slopes have to be opposite reciprocals. But the opposite reciprocal slope of this would be positive 4, 6. So I'm going to go up 4 units, up 1, 2, 3, 4, and then over 6 units, and I land right about here. So when I do this rotation, right, this is exactly where A lands. A is going to land at exactly that spot. So this is the new location of A. And I could do something, oh, and look at this beautiful right angle. Look at that. It's so 90 degrees. And I could do something similar with the other 2 points, but we were just asked to give the location of A prime. So for A prime, we should write down its location is at X is 6 and Y is positive 4. All right, moving on to question number 9. Give the length of segment AC. So here's AC, right? Here's AC, and we're asked what the length of this segment is. And you can see, I can look at this like this right triangle right here. So you can see I've got this little right triangle. This is 1, and this is 1, 2, 3, 4, 5 units, right? 6 minus 1 is 5 units. So using the Pythagorean theorem, this length right here, the square root of the 5 squared plus the 1 squared is equal to its length. So this is looking like 25 plus 1, or the square root of 26. And it does ask, it says you should your answer should be in radical or simplified radical form, not a decimal approximation. So you should definitely enter root 26 as your answer. So the length of that segment is root 26. And again, I know it's not great, but I chose not to put the word units there. I just said root 26. But what are they? They're linear units. It's how long it is. And by the way, I do check these questions. So if you were to type the word units and include that in your answer, almost always I'll catch that. It's not showing though, even though your answer could be marked wrong when you review your test. When you come in and look at it with me, you can see, oh yeah, if I add up the points, you did give me 2 points for that question. So just be aware of that. Number 10, it says solve this system of equation using any technique you prefer. We're going to be looking at some new techniques pretty soon that involve matrices, but for now, let's use the ones that we know. So for example, I'm going to rewrite this top equation so that x and y are on the one side. So I'm going to add 5y to both sides. So this is going to become 4x plus 11y is equal to 31. And then the one below, I'm going to choose to multiply every single term on both sides by 3. So when I do that, that equation is going to become 3x, and then plus 2/3 times 3 is 2y, and that's going to equal -8. Well, that's fabulous, but it didn't make it so that elimination is going to happen, did it? And we don't have to use elimination, but I was kind of going for that. So if I want to use elimination, I'm going to have to multiply both of these, and I guess I'll go with eliminating the x. So I'm going to set out to multiply the top equation by just plain old 3, and the bottom one I'm going to multiply both sides of that, both the left and the right hand side, by what, -4, right? Yeah, -4. And that'll give me 12 on the top and 12x on the top and -12x on the bottom, which would be fabulous because then x will go away. So this top equation, when I multiply it, I'm going to get 12x plus 33y equals 3 times 31, which is 93. And then on the bottom equation, I'm going to get -12x, and then I'm going to get minus 8y, and that's going to equal positive 32. So let's combine those. When I combine the x's, that variable is eliminated for the y's. Look at me with my calculator. What? 33? Scandalous. -8? Are you kidding? That's 25. So I get 25y is equal to, let's see, 3 and 2 is a 5, and then 9, 10, 11, 12. Oh, I get 120. Oh, there's 4 of those, huh? If I take 125 and divide it by 5, I bet I'm going to get 4. Look at me being, oh, I'm gonna get 4. That would be if it's 100. It's 5. Good thing I checked on my calculator because I'd be figuring out what the heck that. Of course it's 5. There's 5 of those that go in there. So let's go ahead and figure out what the x is. So to figure out x, I'm going to go ahead and plug in the beautiful value y is 4 into either equation. I'm going to plug it into, I guess I'm going to use the second equation, the modified form of the second equation. So I'm going to write 3x plus 2 times y, which is 5, equals a negative 8. So 3x plus 10 is negative 8. That means that 3x is the number 18. Nope, not 18. Negative 18. Negative 18. And then if I divide both sides of that by 3, I get that x is negative 6. So here's my answer. I see both pieces. I can write it down. It's going to be the point x is negative 6 and y is 5. So this should be what I type, open parentheses, negative 6, comma, 5, close the parentheses. And you can see that's what that looks like. Next, it says, give the inequality shown by the graph below. Below, it's to the right. Use lowercase x and y in your solution. It kind of does that by default when you type it. So if I look at this, I can see, first of all, I'm talking about y values that are above, right? They're always boop, above. They're above this. But notice it's a dashed line. So it's not greater than or equal to. It's just strictly greater than. So I'm going to say y values are larger than, and then what's the equation of this? What's the expression that generates this curve? Well, the slope of that is apparently down 1, 2, 3, 4 over 1, 2, 3. So the slope is negative 4/3 times x, and my y-intercept is plus 4. So this should be it. Y's are greater than the curve, strictly greater than negative 4/3 x plus 4. Negative 4/3 x plus 4. Enter the inequality shown. Use x as your variable. That was confusing, but then I got what I'm talking about. So on this one, x is my variable. And you can see, because this is a solid dot, it's going to have the or equals to in it. And also because it's shooting off to the right of it, we're going to say that x's are greater than or equal to this boundary, negative 3. So this is x is greater than or equal to negative 3. And that types in pretty nice using the math tools, right? When you type it in, it'll make it look exactly like this. Next, solve this inequality. Okay. So our textbook suggests the following. It says treat it like an equation and find the find the boundary point. So if I looked at this as an equation, I would have 5x plus 12 equals 27. I'm going to subtract 12 from both sides, so negative 5x is 7 minus 2 is 5, and 2 minus 1 is 15, so I've got 15. And then when I divide both sides by 5, I get x is equal to negative 3. So here's my boundary. The boundary, there's 0, and then negative 1, negative 2, and negative 3. Perfect. So which way do I go? Do I shade to the left or do I shade to the right? Well, I can see that this was less than or equal to, so I know that the boundary is solid, right? And then I'm just going to test a value to the left or right and see which side makes it true. When I plug 0 into the original inequality, so I'm going to test this. This is the test, right? What do you mean? I thought this was the test. No, this is the test. I get negative 5 times 0 plus 12. And the question is, what's its relationship to 27? Well, this becomes, is it less than or equal to this? This becomes 12, because negative 5 times 0 is 0, right? 12 is less than or equal to 27, which is definitely true. True with an exclamation mark. So because that's true, I know this is the side, right? This is the side that makes this inequality true. So we shade everything this direction, right? All of these values going off to the right are solutions to this. So that's why the answer is x's, not with the blue pen, although it wouldn't be, x's are those things that are larger than or equal to -3. So this is the answer. A danger, right? If you look at this direction, right, you're very tempted to say, oh, look, it's less than, right? No, this is not right. This is sadness. So be careful. Just think about which side of that expression makes your inequality true. In this case, when I plug in 0, 0 definitely makes it true because 12 is definitely less than or it's equal to 27, right? 12 is less than it. Question 14, solve for x. Well, I've got this absolute value equation, right? And the trade-off to get rid of that is I have to come up with two equations. But before I do that, I really need to get the absolute value portion alone. And to do that, I'm going to take away 5 units from each side. So I'm just going to subtract 5 on each side. So I end up with the absolute value of 3x minus 7 is equal to 7. All right, so I got something equals 7. The absolute value of something is 7. Well, there's two places where that can be true, right? Either it's the case that 3x minus 7, that thing inside, is a -7. Why does that matter? Well, because if this whole thing was -7, when you take the absolute value of it, you would get 7, which is what we want, right? Or it's the case that the 3x minus 7 is a +7. And again, simple equations to solve, right? I'm just going to add 7 to both sides. When I do that first, I get 3x equals 0. Therefore, x is 0. And on the other one, I get 3x is 14. Therefore, x is 14 thirds. So my solutions are 14 thirds and 0, which is right there. And the order could have been different on your test, but that's the one we should have selected. Question 15. Question 15, solve for x. Number line. So I've got that this thing, right, the distance from x has to be less than 10 units, right? This thing, 5x plus 6, has to be less than 10 units either way from me, right? So it's within 10 units. 10 units to my left, 10 units to my right of this 5x plus 6, both sides. So the mechanics, right? We've taken some time to build this up, but we understand that we can write, 5x plus 6, right, has to be no more than 10 away. So I want no more than 10 away from the 5x plus 6. On the other side, right, when I follow my example, the looking inside with the equality, I get this, and I get a -10 over here. Well, now that I'm on the other side of the number line, I can't have it being less than -10 because that would kick it out further away from me, right? I have to have it be more than or equal to. So you see, I've kept this expression keep. I flipped the direction of my inequality here, and this is the opposite. So this is the other half of this inequality. And again, the trade-off, whenever you see the absolute value like this, it has to become two equations to consider what the 5x plus 6 is. So two same steps, right? 5x is less than or equal to 4x is less than or equal to 4/5, and this is less than, so this is an and that joins these. And it also has to be the case that if I subtract 6, I get that 5x is greater than or equal to -16. Therefore, x is greater than or equal to -16/5. And drawing that on the number line, if this is the location, well, let's see. Let's say that here's 0, and way over here, let's see, 4/5 is very close to the number 1. Here's the number 1, and here's like 4/5, and it could be that, so I'll put a solid dot at the 4/5. And on the other one, it says it has to be more than -16/5. Well, that goes in what, 3 times and 1/5, right? So it's -1, -2, that's -3, and then a little bit more, so it's right here. And again, I hope you can see why it is that, because it's kind of a mystery, right? Why do we flip this direction of this thing? Well, if you look at it, right, I can't be it can't be more than 10 units away. And if I said that this was less than, right, it would shoot off in this direction forever, and I could be more and more and more than 10 away. But if I say it has to be within 10 units, right, I'm talking about a very narrow space. I'm only talking about these values that run between the negative 16 fifths and the positive 4 fifths. So all of those points in between there are my solution. And you can see the answer that I've got here, right? They've got on the lowest end, the lowest value acceptable is negative 16 fifths. So I can put that negative 16 fifths is the smallest thing. And then when you look at this, this says is your x's have to be larger than that. But your x's can't go on forever being larger than that. They also have to be less than this one. So this is how you write an and statement into a compact form. By the way, you can only do that with the and statement. You can't join or statements into one statement like this. But this is just another way to read it is just say x is everything in between negative 16 fifths and 4 fifths, including the endpoints. Question 16, another problem very similar. I don't think this will take us much time. I've just got the x plus 13 is less than or equal to 19. Oh, this is less than, so it's also going to be joined by and then I've got x plus 13 also must be more than or equal to negative 19. So I'm just subtracting 19 from both sides, so x has to be less than or equal to. Wait, is there no solution to this one? It didn't show which. Did I not have an answer for this? X has to be less than or equal to 19 minus 13 is 6, right? 13, 14, 15, 16. So yeah. And if I subtract 13 from both sides, I'm going to get x has to be greater than or equal to, that's negative 19 and another negative 13. So that's 9, 10, 11, 12, 32, more than 32. I do not have a correct answer here. So if this is how it looked on your test, hey, this is a free 2 points for everyone. Not sure what happened. Why? Wait a minute. X's are greater than or equal to negative 32. Oh, yeah. And x, oh, it's right here. What's confusing me is that there's no green check mark by this, so I need to make sure that the answer key picked this up and you guys were getting correct credit for getting that one, because that is the correct answer. Okay. And if I was going to graph that just to help me think about it, here's the 6, and way over here is the negative 32. And x's could be the endpoints. They're shaded in. Those x points are included, and it's everything in between those 2 points. Question 17. Solve for x. Okay, this is greater than, strictly greater than, not greater than or equal to. So this is going to be an or statement, greater. Because the distance that I'm away has to be more than 20 units away, right? The distance I am from this expression, 3x minus 5, has to be more than 20 away. So I would say on the one end, I've got the 3x minus 5 has to be greater than 20, or the 3x minus 5 has to be less than negative 20. And it's what nice is we're building it the exact same way, right? Once we understand how to do this, it's not like it keeps changing each time. It's pretty much the same thinking. Add 5 to both sides. 3x has to be more than 25. Divide by 3, x has to be more than 25 thirds. Or add the 5, you've got 3x is less than negative 15. So therefore x has to be less than negative 5. So x has to be less than negative 5, or x has to be more than 25 thirds. And you can see this is the answer that says both of those. It's less than negative 5, or it's the case that this. On the number line, if I think about it, here is the number negative 5, and it can't be negative 5, so I've got an open dot. 25 thirds is like what? I don't know. How many times is 3 going to 25? Mr. Roberts, 3 times 7's 21, right? So it's like 21 and 4. It goes in more than that, Mr. Roberts. 3 times 8's 24. So it's like 24 and 1/3, right? So here is 24. no, 3 times 8 is 24, so it's 8 times, and 8 times and 1/3, so it's like 0, 5. I'll just imagine that this is positive 8 and then 1/3, so it's here, right? It's an open boundary, and then the points are all of the ones that live in between those two, points. So that is the model of our solution. And the thing that we have written down over there does say exactly the same thing. And of course, if I was to pick any of those numbers between -5 and 8 1/3, they would all make the original inequality true. For example, if I put 0 in, just for fun, right? If I put 0 into that, it becomes 3 times 0 minus 5. I take the absolute value of that. That's going to be 5. The absolute value of -5 is 5. 5 is uh, 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 it doesn't work. It completely doesn't work. Oh, yeah, because Mr. Roberts, it says you got to be less than the -5. Mr. Roberts, what are you doing? Is it time for you to take a nap? Yeah, why are you talking to yourself, Mr. Roberts? It's time for you to take a nap. You seem like you're not doing too well. So yeah, this was 8 1/3. Here it is. So let's look at what this says again. It says x's are either less than negative this way, right? Or they're more than it this way, right? So of course, it's kind of nice to see that, yeah, when you pick values inside of here, none of these work. -5 wouldn't work, and a positive 8 1/3 wouldn't work. You'd have to be outside of these regions, right, before you get things that work. Oh my goodness, nap time is here. Final question number 18. It says, given that both x and y are constrained to be positive numbers, okay, positive numbers. Is 0 positive? I don't think 0 is positive or negative, right? 0 is 0. The positive numbers are, I don't know. I'd have to ask Google or something. So give positive numbers. Given a whole number. It's not given. It should be give. Thank you, Trinity, for pointing out my mistake during class. Give a whole number, no fractions or decimals, solution to the system of inequalities. So what is a solution to a system of inequalities? It's a location, right? So I'm looking for an xy that makes this true. And the solutions by all of these three constraints, and you can see here they are, those are the constraints. The solutions that are whole numbers are either that xy, this xy, or this xy. So you could have entered either 1, 3, 1, 4, or 1, 5. This point right here would not work because this is a dashed line, so it can't be, although it looks like it totally goes through that, because it's a dashed line, it would not satisfy two of them. It wouldn't satisfy this inequality or this inequality, although it looks like it would satisfy this one, right? This one would be fine. This one would be a no because it's on the line. This one would be a no because it's on the line. So again, your answers are either 1, 3, which is like this, 1 comma 3, or 1 comma 4, or 1 comma 5. Either of those 3 points, I was going to say 4, 3 points would work. I believe that's our last question, right? That was the study team test. I don't know what else to say. I hope that you found that fairly straightforward. A lot with the inequalities there, a lot with the directions and stuff. But we're winding down right before spring break here. We are going to take this Chapter 9 test on Friday. This is Mr. Roberts. Have a great evening, and I'll see you in class.